All right, so question number 1, they are giving us the value of 2 integrals, and they're asking for the value of this third, which is a combination of these two. So I think the best thing we can do is to split this into 2 using our sum and difference property. And when I split this one up, I'm going to pull that 3 out in front. Now, the 3 doesn't go in front of both, right? There was no 3 in front of g. All right, so what can we put in here? We know the integral from 2 to 6 of f is 5. So this right here is equal to 5, so we've got a 15. Then they told us the integral from 6 to 2 was 7, which means the integral from 2 to 6 is -7, giving us our answer of 8, which is letter B. All right. Similarly, let's take a look at number 2. They give us the value of 2 integrals, and they want the third. So what I'm going to do is I'm still going to split this into 2 pieces. So I've got the integral from 0 to 5 of 3 dx, plus I'll slide the 2 in front, and then I want the integral from 0 to 5 of f. All right. Why did I do that? Well, because this, you can take the antiderivative, or you can say they're looking for the area under y equals 3 from 0 to 5. That's a rectangle. The base is 5, the height is 3. So this is 15 plus 2 times blank. So we need the value of the integral of f from 0 to 5, which we do not have. We have, I'm just going to draw a picture here. They told us, this is not a great picture, but they said the area from 0 to 3 is 6. The area from 3 to 5 is 4. Well, the additivity property tells us then the area of the whole thing is 10. And 15 plus 20 is where we get our 35 from. All right. So let's take a look at question 3. So they give us the graph of f prime. They tell us the areas of these 3 regions. They give us an initial value. What is the maximum value on f, this is f prime, on the closed interval 0 to 10? We know maximums can come from endpoints or critical points. And critical points for maximums are where the first derivative changes from positive to negative. So there could be something going on here. Maybe I call that lowercase a. And something going on here, lowercase b. Now actually I would rule that one out because that's going to be a minimum anyways. So forget it. All right, they told us the y value at 0 is 2. I would like to find the y value at a. Don't forget, the area under a derivative tells us the change in the original. So my y value is 2, but then I go up by 20, so now my y value is 22. And I need to still find the y value at 10. So I'm at 22, and now I'm going to go down 6, which puts me at 16. And then I'm going to go up 4, so the y value at 10 is 20. So the maximum value overall is 22. So we've seen this multiple times in this packet and in the ones in class. When we talk about maximums on a closed interval, you must look at the ends or rule them out somehow. All right, so let's take a look at question 4. What is the total area of the regions between these 2 curves from 1 to 3? It is not a calculator question, so make sure we don't touch that. So, oh gosh, if I wanted to find total area, I want to know, like, where is the area? Where does it start? Well, we know we got this 1 and 3, but let's take a look at what's going on. This is a parabola, and if I factor out a 6 and an x, this parabola crosses the x-axis at 0 and 3. And it opens up, and then I have y equals -6x. Probably something like that. right, is a line going through, I missed the origin, you know, but, and then we're going through the origin with the negative slope. But they want the area from 1, which that's not great scale, to 3. Ooh, so it looks like we're going to need 2 integrals, and we're going to need to find where they cross. Well, let's find that first. So I've got 6x squared minus 18x equals negative 6x. Or, let's see if we add 6x squared minus 12x equals 0. Okay, well that makes sense visually, you know. I have 2 intersections, 0 and 2, which we knew about the 0. So we are going to integrate from 1 to 2. Come back to that. And then we're going to integrate from 2 to 3. All right, my first integral, I need top curve minus bottom curve. My top curve is the line, negative 6x, and my bottom curve is the parabola, 6x squared minus 18x. We'll distribute the negative, combine like terms, take the antiderivative, plug in the bounds. This is actually quite a bit of work. My second integral, the top curve is now the 6x squared minus 18x, and then I'm going to subtract the bottom curve of the negative 6x. So watch that double negative there. Combine like terms, take the antiderivative, plug in the bounds. So it is quite a bit of work, but you're going to find that some multiple choice questions are more work than others. I'm not going to finish this. If you then struggled with the arithmetic, come see me and we'll take a look. But that's the setup. We need find the intersection. How many regions do we have? That's how many integrals we need there. All right, let's take a look at question 5. So this graph may look familiar. I think I used it in your homework recently, but they tell us that the regions of A, B, and C are 14, 16, and 50. Actually, it was on your last test, I believe. What is the average value? The graph was on your last test. This question was not. What is the average value of f on the closed interval 0 to 8? If I want to find average value, we're going to add up all of the function values from 0 to 8, and then we divide by 8. Now remember, the integral says go find the net area under f. So I'm going to find the net area and divide it by 8. So I have 14 minus 16 plus 50. So let's see, what is that? 48 divided by 8, which is just 6. All right. Question 6. Here is the graph of f. G is defined by the integral of f. What is the value of g of 5? Well, g of 5 is the integral from 0 to 5 of f of t dt, f of x dx, whatever. You know, it doesn't matter. The most important letter there is that we talk about the letter f. So we're going to go look for the net area under f, which we have from 0 to 5. Now we have a lot more than that, but we're going to start at 0 and we're going to stop at 5. So this is a semicircle. Diameter is 4, so the radius is 2. So 1/2 pi times 2 squared. This is a triangle with a base of 1 and a height of 3. So 1/2 times 1 times 3 is 3/2. So I have 1.5 plus 2 pi. Good. All right, let's take a look at number 7. So lovely piecewise, and they're asking for the value of the integral. I say we just go take a quick little look at the graph. I have x squared when x is less than 0. When x equals 0, I'm down here at -1. And then I have the line y equals x when x is greater than 0. There's a hole there, right? They want the value of the integral from -1 to +1. Right? And we've said the discontinuity should not bother us. We're going to find this piece, we're going to find this piece. Now, I'm going to start with a triangle. This is 1/2 base times height. The area of that triangle is 1/2. Okay, first of all, I know that's not true, and I know that's not true. Okay, I need to find the area of this. So how do we do that? We're going to integrate from -1 to 0, x squared dx. So I have my 1/3 x cubed. When I plug in a 0, sorry, I'm going backwards, that's poor form. I get 0 minus a -1. So 1/3 times 1. So 1/3 is this area, 1/2 is this area, so I want 1/3 plus 1/2, which is 5/6.